So now we'd like for our play hit action to actually have a knockback. So we could pull a value out of, let's say, the blackboard, which would be the vector of the direction that the character was hit in, at least the last hit, and then move the character basically backwards from whatever direction it was being hit from. Okay, so in order for our character to have a knockback effect trigger on it, then we need to get from the Hurtbox, probably on this hit function, a knockback value, and that should be determined by the projectile's properties or any attack that's hitting the character. And then eventually we want to get that set on the blackboard setter so that on the play hit action we can pull that data out and then use that to basically move the character in the direction it should be while it's in that hit stun state. So there would be something like a P knockback vector 2D in addition to that, but if I think about it, I might also add in how long the duration of the hit knockback should be, which could vary depending on the weapon. So maybe a big hit is a long knockback and a tiny swipe at a character should only be a stun for a fraction of a second. So to handle all of that, since that would be 3 or more parameters and we might add more later, we might also want to create an object to handle hits rather than just passing the damage value in here. So that'll mean that our was hit will change more to like a hit parameters as a object rather than passing a integer value. So we can basically add as much data to that object as we want. And as a result, we can have a much more complicated hit setup without creating too many extra parameters. So in our project, it might make sense to put it in data, but also weapons kind of makes sense. And since we're talking about things that are hitting other things to deal damage, I think putting our object script in weapons actually makes a little bit more sense. So I will create a new script in weapons, and I guess calling it something like HitData makes sense. So this will be an object, not a node. So basically, we don't need to add it to our scene hierarchy. It's just a pure data object. So that's why using object makes more sense than a node. So there's no need to have process or physics process running. We just need to pass data from one other object or node to a different one. And we'll do that with our data object. So hit data, create, and inside of our hit data, we can give it a bunch of fields. We don't make them export values though, because a object is never going to really show up in the inspector. So we're not exporting it to the editor to be edited. This is only going to be basically persisting during gameplay and only then. So our hit data is going to consist of the object that did the hitting, I think. So we could say the hitbox that attacked, that will be a hitbox 2D. We also want to probably get reference to the Hurtbox that got hit. So the Hurtbox, we probably want to have the damage that was incoming and then the damage dealt. So we could say damage dealt here, which is going to be an int. But before we calculate the damage dealt, we're going to have the damage expected. Yeah, that makes sense. And what else would we need? The knockback vector. So knockback, I guess we'll call it force. Since we're dealing with character sprite 2Ds, it's not exactly like a physics force, because we're not treating them like a rigid body in this game. We have to basically hard code the movements. And that's part of the difference between the character body 2D and a rigid body, which would be pure forces, like the projectile. So the knockback force is going to be, of course, the vector 2. Knockback duration. Knockback duration is going to be a float. And we could default this to something like 0.25 if we want. I'm also going to tab these all over so that I can see easily which type is which. Okay, yeah, that's a little bit cleaner there, and maybe this gets an extra tab. So when we create our hit data, there's a couple different ways we can do things. One would be that we don't create a custom init function, and then we'd have something like a create hit data function in another script, and we do something like var data equals hitData.new. That's not going to work right now because we need the class name up here at the top. So class name HitData. And then now with data, you can assign each of these properties individual, which could be handy in a sense that you aren't forced to actually include any of these properties when you create the data. But it might also be kind of messy because, especially if you create new fields that are required, you may forget to set them in your script. So I think I would lean slightly towards doing function underscore init. And then when we have our init function, we pass in the parameters, including the required ones and the optional ones. And then if we ever change it, we'll get errors in our code so that we'll know to actually go back and update it. So I don't think we would update HitData too much with new properties, but when we do want to make sure we account for that. So let's start with the required ones. P Hitbox is going to be a Hitbox. And I'm calling them P for parameter because I'm going to be saying like Hitbox equals P Hitbox. So we want to make sure we're specifying the property in the object and the parameter we're passing in as two different things. So that's a Hitbox 2D. And then we're going to have P Hurtbox, which is Hurtbox 2D. And then we're going to have the expected damage. So damage expected, which is a int. But you know what, while we're ahead, there might actually be a situation like a healing projectile, for instance, down the road where we might change the health, but it's not necessarily damage. So let's account for that in advance. So we could call this like health expected and then health change. Okay, and then this should be P health expected there. So we're not actually going to pass in health change as a parameter here because when we create the hit, we haven't processed the health change yet. So we'll update the health change manually, probably on the Hurtbox or after that, to set back in the data what the health change value is for anything that needs to know. But we'll have the optional parameters, knockback force and duration. So P knockback force as a vector 2, and that's going to equal vector 2.0 by default. And then we're also going to have P knockback duration, which is a float. And then that'll just be equal to 0.25. Yeah, I guess so. And then I'll remove the default up here. So these are our required parameters, and then these are our optional ones. I guess the knockback duration will actually be 0 by default. So if there's no knockback, I guess that is what we want the default to be. So if we want a knockback, we'll have to set a manual direction vector and a manual duration here. So we can see I'm getting a expected indented block after function declaration. So we need to hit enter and do a pass. So we need to hit enter and give it a pass to actually add the function. And then up here, Hitbox 2D. Ah, I see. When I created the name Hitbox, it was lowercase on the B. Yeah, I think that's fine. I might change that later, but I think calling it lowercase Hitbox is okay. Okay, so change that, and then now we want to actually implement the init function. So this is going to be pretty simple. Hitbox is going to be equal to the P Hitbox. The Hurtbox is going to be equal to P Hurtbox, and so on and so forth. So health expected is going to be equal to P health expected. Knockback force is going to be equal to P knockback force. And duration is going to be equal to the knockback duration. So I don't super like the property name health expected. I'm going to try renaming that in all cases across our script. So you double click this, you control R, and it's going to try to rename health expected, including where the variables are prefixed by P underscore, and it's going to change those to whatever we want. So I'm going to say maybe amount, because when you hit, there's an amount of change and you would expect that. So I think that's still pretty clear, but easier to type. So I'll rename, and now you see it's now P amount, amount equals P amount, and amount up here at the top. So just keeping like the shortest possible variable name that's still very clear about what it actually is. And if you need to specify more about what each is supposed to be, then you can go up here to the top and you can do a couple hashtags, or really just one. If you do 2 hashtags, it adds it to the documentation. which actually, no, that should be there. So let's add in a comment here. The hitbox, which hit the hurtbox, I guess you could say with a move or attack. And then here, the receiving hurtbox of the move or, and then over here, you could say the amount of health change expected on the target. I think actually the health change, because that's not part of the original data, I'm actually going to remove that from the hit data. We might not need it to be in the hit data because this is more of the reaction result, which could be emitted in its own signal on, say, the hurtbox, rather than the data of the hit being transmitted to the hurtbox, so to speak. So I don't know. Maybe we'll add it back in later, but I'll have to see. Okay, and then the knockback force is the direction, and the force amount or the magnitude. I guess magnitude of the knockback would be more technically correct. And then the duration is the length of knockback, keeping the character in the hit. Well, not necessarily. We'll just say the length of the knockback duration. Because not every character is actually going to play the hit action. Maybe some characters just completely ignore the knockback duration and they continue moving as normal. So it's not necessarily a certain thing that the play hit action will be going on every character. That's just the expected default for right now. Okay, so that pretty much clarifies this class pretty well. So if we were to click search help and look up hit data, we should be able to see all of the information we just typed up here as documentation for this class. The class itself doesn't have a description yet. If you want to do that, up here at the top, we could say data properties concerning when a hurtbox is hit by a hitbox, move, attack, or action. Okay, so now if we look up hit data again, we'll see that that just pops up there. So it's like instantly created documentation, which is a pretty cool part of Godot. And I think we can even click the properties and jump right to them. Yep, pretty handy. So now back in Hurtbox for the hit function, instead of receiving the P damage int, we can actually just receive the hit data. So let's do hit data. And we can say P hit data underscore data. I'll also make that what gets emitted here. So hit data, when the hurtbox is hit with the hurt data, we can emit that. And now from the hit data, we want to minus equals the P hit data dot amount instead of the P damage. So regarding the damage dealt, we can add that back into the P hit data. And I know I just removed that field. So we'll say P hit data dot actual or changed, actual change. Yeah, I guess actual change, sure. It's going to be equal to the damage dealt. So this is going to be a negative value. So since the change doesn't really specify if it's positive or negative, we should say -1 times damage dealt. Okay, now we need to add this hit data property back in. So under amount on hit data, the actual amount of health change that resulted on the target for actual change, it's going to be int. Okay, so setting the data back on the hit data, and then when we emit the data into this hit data, it's going to have that property. So it's basically taking the data, updating it, and then re-emitting it from the hurtbox for anything that needs to respond to this. So we're going to emit the p hit data down here after modifying it, and then we return the damage dealt, I guess. Let's see. Actual change. Let's rename the values here. So I'm going to rename damage dealt to actual change. And then we'll say -1 here times the old minus the current health. So if it's dealing damage, it's going to be made negative here. And then we don't need to make that negative here. And we return the actual change. So let's give this a comment. So this hit function changes the health value on the health component. It adds the actual health value to the p hit data, and it will return the actual amount changed. So if this is a negative value, we know it dealt damage, and if it's a positive value, then we know it actually healed the character. So basically, the hit function can be used for both heals or damage dealing effects. That way we don't have to create separate functions for that. So that's going to do the hit. Was hit is going to trigger. We're going to get the hit data, which means if we go back over to the object Blackboard setter now, was hit is going to be expecting the p hit data And if we hit play and tried to run it, it would probably throw an error and we just end up over here at an error point. But I'm just doing this preemptively. So the hit data is going to be that. So let's see, the global names keys is hit. Instead of setting a Boolean, what we can actually do is just pass in the whole hit data. And that will mean that on our play hit action, we can just pull all of that information from the one data object rather than just the fact that it was hit. But now we have access to everything else inside of the play hit script, like the knockback vector. P hit data, we'll pass that in, P hit data. And instead of keys is hit, we'll do keys dot hit data. Okay, so that of course means we need to jump into the keys, Blackboard keys, and we're going to update this. So instead of checking if the Boolean is hit, we'll check if there's an active hit object assigned inside of the Blackboard. So basically, if the character's hit, there'll be a valid object, and if it's not, then there won't be a hit object. So we'll have var hit data, and this is going to be a string name still, and we're going to be looking for hit data. Okay, so we can get rid of the property is hit. Now let's jump over to the play hit action, or the play hit condition, really. So we're going to be checking for var hit data is equal to pBlackboard.getValue, global names, keys, hit data. And by default, that's going to be null, which is the default value. So we don't need this anymore. So if the hit data is not null, which can just be this, if hit data, then we return success, else return failure. So basically, if there's no hit data, then we're not doing the play hit action, which means that if we go to play hit action now, we're once again going to be getting that hit data, and we can do that up here, and we can do that on before run. So var hit data, and the before run, let's see, we're going to be getting the hit data from the Blackboard. It's going to be equal to, and this should be pBlackboard. And I'm going to make this pBlackboard to make it consistent with this over here. So the parameter Blackboard is going to get the value. The key we're looking for is the global names dot keys dot hit data. So we do expect that this is going to be there. If it's not there, that's really a problem. So we're going to assert hit data does not equal null. Or we could say is instance valid hit data. So when you do an assert, it's only going to trigger these asserts during development mode. But it's a big problem if we try to run the hit action and we don't have hit data here. I mean, we're probably going to get an error anyway, so this isn't necessarily required, but we could have it there anyway. Hit data must be set for the play hit action to run. Just kind of like as an extra there. So we really want to emphasize we have to have hit data for this play hit action to work. Otherwise, we're going to run into problems. So since we got the hit data, and this hit data is going to be consistent for our entire play hit action, we don't need to keep pulling from the Blackboard or anything. We just need to use the data as we would expect. So for our hit knockback, it's going to have a knockback stun, right? That's the knockback duration. And we only want the hit animation to actually play if there is a knockback stun of sorts. So if the duration is set to 0 seconds, then we would just skip playing the animation actually. So we can say if hit data dot knockback duration is greater than 0.0 seconds, then we're going to play the animation. We're going to connect to animation finished, and we're going to set is playing to true. Otherwise, we want to enforce that is playing is false because there's no knockback. There's no stun. So basically, as soon as we finish up with this function running one time, we're already done with it. So we should just return success. So is playing is going to be false. It's going to come to the tick on the next update, and it's going to return success down here. And what we want to do is instead of setting the Boolean to false, we want to set the property of the hit data. We want to set the variable, the hit data, to null. So we're going to take global names.keys.hit data, and we're going to set that to null. And because that's null, the next time it tries to look at the is hit condition, it's going to be basically null, and it's going to return failure, which means it's just going to move on to the wander action rather than the play hit action. So just like with the wander delay timer, we're going to have a knockback timer, though it's going to be specifically set up for each of the hit data. So if one hit has a 0.5 second timer, we're going to do that. Otherwise, it might be a 0.25 second timer or a 0-second timer. It makes sense to have the node here, wander delay timer, set up externally so that we can customize that for all of the wander actions for the character. But the play hit timer is specific to the hit, and we don't know about the hit yet, so I would just create the timer in code. So the play hit action, honestly, we could just do @onReadyVar hit timer of type timer. So honestly, we could just do a @onReadyVar. So @onReadyVar hit timer is going to be equal to timer.new. And then instead of connecting to the animation finished signal, we'll set up the timer, play it, and connect for the timer to timeout. So let's say timer or hit timer dot play, and we're going to get the hit data dot knockback duration. We're going to connect to the timeout. But you know what? Let's do that up here rather than in the before run. So we have the hit timer. When this gets set to our value on loading, then the hit timer is going to equal the value, and we want to do hit timer dot timeout dot connect, and we'll say on timeout. Okay, and we'll create that function at the bottom, or really, let's just rename this to be on timeout. Okay, so since the hit timer is just going to be set up here on ready, we just connect once. We really don't need to connect to it every time the animation stops or finishes. So we can get rid of this line and this line down there. Whenever the timeout occurs, is playing is going to be equal to false. And let's make sure that after the run that we stop playing the timer just in case it happens to be running. So function after run, p actor node, p blackboard, and then returns void, and we'll say timer.stop or hit timer.stop. Hit timer.stop. Okay, and that'll make sure that it is completely stopped until the next time we come in here, so there's no funny things going on with the signal callback. Okay, let me just give this a quick skim. We have the hit timer. We get the hit data assigned on load. When we stop playing, then we should set the hit data to null. I guess we can take this line and port it up here so that, no matter how we exit the after run, this will always set the hit to null after the hit action is done being played. Okay, so that should be p blackboard there. This can be underscore p actor because we're not using it, and underscore p underscore blackboard because we're not using it. You can see in the debugger that actually there's like a lot of unused variables. I can click on those and try to clean them up. So basically whenever a value is not being used, you can just underscore it like so to get rid of those warnings. And I got quite a few right now. So let's see, p actor, and here we have underscore p blackboard. Okay, so let's run the project and we'll see kind of where we're at. So when our hitbox hits the Hurtbox, before we were passing in the weapon stats damage. So we can see that this now requires a hit data. So before we hit the Hurtbox, we need to create an actual hit data. So we'll say var hit data is going to be equal to hit data.new. Okay, and make sure to spell that right. It should highlight green. And then we need at least 3 parameters for the init function. So if we check so I'm going to close out all these scripts over here. And if we check the hit data init, and you can do that, I think, just by right clicking on new, we come down here to init. And you can see that we need these 3 parameters. Looks like there's also a bit of an issue going on here. Can't parse hitbox 2D. So it might be hit and then capital box for the B. Let's take a look. So I got hitbox 2D. Oh no, the reason is because I just wrote a line of code which isn't valid. Okay, so we need these parameters. So hitbox, Hurtbox, and amount. So the hitbox is self, of course. The Hurtbox is the one we just found, the Hurtbox. Okay, and when you hit comma, you can see the parameters popping up. So next is the amount, so the damage, which is weapon stats.damage. And then we need the knockback force. For right now, we'll not do that. We'll come back to that. So just save that. And then when we are emitting the signal, rather than passing in the Hurtbox and the delt, why don't we just do the hit data as one parameter? So hit data. Now we can wait for the dealt damage to come back, which is also going to update the hit data. So let's pass in the hit data here, which gets updated, and then we can emit the hit data. Up to us if we want that to emit before the Hurtbox receives it or after it. And then the Hurtbox processes it and everything else. I don't know, that just kind of depends on what you want. Like if when the hit is done, if you want to have that final damage dealt data being emitted with the signal, or if you want it to just be before the Hurtbox processes anything, then you can put the hit.emit before this Hurtbox.hit function. That is entirely dependent on kind of what you're looking for, like timing wise. But either way should work for the most part. It's just one will have the actual health changed like this. And then if you put it before, then it won't have that data. So invalid argument for hit data, but is end. Yeah, that just means we need to rerun it. So if we hit play, yeah, we're probably going to run into a few other minor issues. So let's see, is hit no longer exists? So yeah, when we're doing the wander action, instead of checking is hit, what we should be checking for now is hit data. So keys.hitData, and then this will be of type hit data, of course. So if the hit data is valid, so basically if is instance valid hit data, then we want to return failure, because if there's a hit to process, we want to break out of the wander action. So this is on the wander action that we're talking about right here, of course, from the previous video. And yeah, these are just the kind of updates we'll need to make when we kind of change our data structures around. We hit play. Yeah, I guess right now that's pretty much it. So let's shoot a character. Interesting. It just passes right through them. Let's see what the debugger says. Error calling hit. Because we changed the parameters. So let's click that. And this is on the projectile.gd. On hit expected 2 arguments. All right, so we need to go into projectile.gd and we'll check this. So on hit is actually going to be receiving the hit data. Right. So the projectile hit the target and now we need to free it. But in order for that to work, we have to have the right parameters. So p hit data. We're not going to be using it, so I'll underscore it in advance. Now this kind of also illustrates why having a object that your data structure for all of the parameters that are going to go into a hit is helpful, because your signal is always going to emit as hit data. What hit data consists of may change as you update your project, but instead of having 2 parameters become 3 parameters and then it breaks all of your signal connects, you can just always have it be hit data, and then you customize hit data internally and all your signals stay glued together. So one advantage of just having a single parameter for a signal like this, especially when the data structures are kind of complex. Let's close and play again. So if we hit play and we hit these characters, then we can see basically for a fraction of a second, it's probably just a single frame, but they do kind of stop playing the wander action. Because it's not about dealing damage, it's about whether the animation is going to play or not. It's on the is hit condition. We'll check if the hit data is there and return success. And so before passing this on to do the play hit action in the hit sequence, let's also check if the hit data.knockback duration is greater than 0.0, and then we'll return success. Otherwise, we're just going to return failure. The reason for this is that I don't want this to interrupt the wander action with the play hit action. So let's hit play and see if that works. So we shoot the characters and okay, that kind of broke them. Let's check the debugger now and see what's going on here. So it's in the wander action. Yes. So we can see that it doesn't actually remove the hit immediately. Yeah, okay, maybe what we can do is we only actually set the hit on the blackboard if we need it to be processed. So rather than checking the hit duration right here, we'll still have the play hit action exit out of the hit basically immediately if the knockback duration is 0, but it's still going to run the tick 1 time, which means it's going to be not in the wander state. So in the object blackboard setter, we'll only set the blackboard value if the hit data duration is greater than 0. So if phitData dot knockback duration is greater than 0.0, then we'll do that. And maybe this calls for a comment. So because the blackboard is going to be helping us control our logic here, and we only want the play hit data to interrupt the blackboard with the play hit action instead of the wander action, if the knockback duration is greater than 0, then I will set that there, that we only do that if the knockback duration is greater than 0.0. So that might not be the best long-term solution. There's probably a little bit more of an elegant way to write this, but I think that'll work for right now. So if I shoot a character, you can see now it doesn't interrupt the wander state at all because there's no knockback duration. So it stays in the wander state because the hit data was never set on the blackboard to interrupt it. Is hit condition never returns true. It's only failure. So now we need to actually give our projectiles that knockback stun. So let's check out the stats, the weapon stats. Okay, weapon stats basic. We want to add an extra property to that. So I'm going to edit the script. So we have weapon stats. Let's say export var knockback. Yeah, sure. Let's do knockback force. And this is going to be a float because we don't know the direction yet. The direction is calculated based on the positions of when they are hitting each other. So this would be, I don't know, something like 100 pixels per second. And then at export var, the knockback duration is going to be maybe like 1/10 of a second. But you know what? I also noticed that kind of these properties are getting grouped together. So I'm going to go one step further in advance now, and I'm actually just going to create another data object for knockback. Yeah, so just bear with me here. Let's right-click on weapons, and we'll do a new script. So this will be a resource to define a knockback, and this will be knockback.gd. We'll create that, and then let's just pull these into that. So class name, knockback. Maybe we call it KnockbackStats, actually. Okay, and we name the script. So knockbackstats.gd for knockbackstats. And then this will define the force and the duration. So the duration can be a float of 0.1 second. I think that's probably plenty, honestly. And now we'll have weapon stats. So we can have at export var knockback stats. Okay, and if we check our weapon stats basic, we can see knockback is empty. So if we don't want a weapon to have a knockback, we can just leave this blank, and then we don't need to check the duration. We can just see if there is a knockback or not. We do want the basic weapon to have a knockback, so I'll create one. And we have the defaults of the force and the duration. This is also handy if we add more stuff to how this knockback should work. Okay, so now on our hit, so let's see, that would probably be in the Hitbox 2D. We get the weapon stats damage. We're going to use that to create the hit data. So let's see. The fourth parameter can be weapon stats.knockback. Okay, now that isn't a parameter inside of the hit data. So let's look up the hit data. And we'll have one variable here for the knockbacks, which is of type knockback stats. And the force and duration of an expected knockback on the Hurtbox's character. Okay, and we can remove the force and duration here. So as our extra parameter, we're going to have p knockback of type knockback stats. This can default to null. We don't have to set it. And then we remove these extra parameters here like that. And then we're going to have knockback equals p knockback. And we get rid of that bit. Okay, so basically we combined two properties into one new object. So we're reducing the number of parameters that this hit data has by kind of nesting the data objects. And also it gives us the ability to just check if the knockback is null or if there is one. And if there's not one, then we won't set the hit condition on the play hit action. So if we open up the Blackboard setter, now we can just check if the knockback exists. So if the knockback exists, then we can set the p hit data on the Blackboard. And maybe we do want to set the hit data on the Blackboard whether or not it has a knockback. So we'll just set that in there. So on the is hit condition, we do check if it's hit. We could also check here if the hit data has a knockback, but I think that might make sense to actually add an extra condition before we go to the play hit action. So let's create a new condition leaf here. Add a condition leaf. So I'll say HitHasKnockback condition, and then we'll create that as a script. So HitHasKnockback condition, I think we're putting everything in objects still, right? So we got our conditions here. I might actually group all these conditions into a folder soon. But for right now, I guess we'll do HitHasKnockback condition.gd. Okay, open that. Oh, make sure it actually extends condition leaf. And then we'll create that. And we'll copy this tick function over like this. So I'll say if HitData.Knockback. I guess we can actually eliminate the isHit condition from this sequence, and we'll just do if HitData and HitData.Knockback. Now, the isHit condition could still be useful for other things, but here we're checking that there's a hit and it has a knockback. So really, I guess naming-wise, this makes more sense. So we can actually just remove the hit condition from the tree. I'll leave the script in the project because that might be there for other things. So here we're checking if there's a hit data and the hit data has a knockback, we're going to return success. And I think that's good. So let's hit play and let's see if this works at all. So I hit this character and we get to the play hit action, which is good. But we have the HitData.Knockback duration is greater than 0. So we're going to do HitData.Knockback.duration. And then this is knockback.duration. And then I think that's all we need to do to update that. So we have the knockback object on the hit data, and then we have the duration there. So let's shoot these characters again. And we have hitTimer.play, non-existent function play on a hit timer. That's interesting. So the hit timer is null, supposedly. So the problem there is that it's called .start for a timer, not .play. So let's hit play one more time. We're going to shoot one of these characters. Okay, and he gets stunned. These characters get stunned. Okay, so let's see what the debugger says. Timer was not added to the scene tree. Either add it or set auto start to true. Okay, so I guess what we'll do on setting the timer is we'll add it as a child to our action leaf. Okay, let's shoot them again. Okay, and this time it seems to be playing. Timer was now added to the scene tree before run. Okay, so let's hit play again and shoot a character and see that timer was not added to the scene tree. We can see it's not, so maybe we need the ready function here as well. Function underscore ready, and we'll do add child, hit timer, set a breakpoint, hit play, and we'll make sure that works. Okay, so we have the hit timer, it's getting added now, and that would mean that when we hit a character, it should not throw a bug. But we can also see it never exits the state. So is playing getting set to false is what we need to exit the tick. But that's not really getting set there as well. I think maybe on ready doesn't work with set as I thought it did. So we can just bring this code down to here. And I believe onReady runs before the actual ready function. So we'll add the child and the hit timer connect down here. Okay, and we don't have a setter there. So the setter works really great for export properties, where you define something in the inspector and then it gets set on load. But I guess maybe for onReady, it's not as simple as that. So let's hit play and let's shoot a character. Okay, and now we can see they do get stunned for a 1/10 of a second there. So that's good, that's what we're looking for. So at this point, we can see that our hit data is working, passing between objects because we have the 0.1 second stun on the character when they get hit. We haven't applied the knockback velocity yet, but since our hit data is set up for that, that should be pretty easy to set up in the next video. So next we will work on continuing with the hit state of our character. Now that the hit data is much more robust and set up, it should be easy to add in the knockback vector next.